Here's my replication of Lasersabers Super Joule ringer circuit. With all the crazy stuff that's happening, I kind of wanted to have an independent light source, kind of like a modern lantern, in case we have power outages or grid down scenarios or anything like that. But I chose this circuit because um, he demonstrated that it has a ability to light these 120 volt LED bulbs, which probably last, I don't know, 5, 10, 20 years. And they're all over the place now, and they're super cheap, and they don't get hot, and they're low wattage. And this one right here is a 100-watt equivalent. And what I found is, those little tiny USB LED bulbs that you plug in. Well, I actually tested it, and they actually draw about 5 watts. And I can get more light output with this circuit than on running off of 2 watts than one of those plugged in. So as far as like energy conservation and longevity of runtime, I decided to go with this arrangement. So initially, when I started experimenting with this coil, which, by the way, this is a 4-inch ferrite, half-inch diameter ferrite core rod, it was like a spaghetti mess of alligator clips and stuff. So I decided to clean it up and put it in a little package. But the power, it does require around 12 volts. So to get around that, what I decided to do is use an 18650 lithium ion, which I like this kind. I think it's a Panasonic. It's got a built-in circuit protection board right here to prevent it from overcharging, over discharging, and that's just like a redundant thing, because this little USB-C charger board kind of has the same function, but these have a lot of storage capacity, so I'm still kind of testing the runtime on this, and it's pretty bright, it's pretty useful. But anyway, so this USB-C charger board kind of maintains and charges the battery. I got to run through a switch and through a little digital LCD voltmeter, and then it runs through this 2 to 30 volt 2 amp boost converter circuit board, which this potentiometer counterclockwise increases the brightness of the LED, but it also increases the current draw. So, but with this setup, you can get pretty bright light out of this, and you can run it for kind of a long time. But anyway, as far as the coil goes, it's basically the inside wire. I'll call it L2. The L2 winding is basically 3 layers of 26 gauge wire, and then it's got the L1 coil, which is the outside coil, is just 1 layer of 19 gauge wire, and it's all wrapped in the same direction, right? I'll show you the circuit here in a second, but I want to show you how this thing works. So I actually plugged in 60 watt equivalent bulbs, and at the current setting, it's of course drastically reduced current draw, but at a reduced brightness as well. And for anybody that's wondering, this 3055 transistor stays cool. It does not get warm at all. It's room temperature, and it maintains that. In this voltmeter, that's the voltage on the actual 18650 cell. So it's basically tapped straight into the battery. And interesting enough, when you charge these things, if you guys want to buy some of these, don't charge them with anything over a 1 amp brick. And what I mean is like a charging brick. Make sure it's 1 amp, because I tried a 2.4 amp charger, and this little component right here, I don't know what it is, but it got really hot. Super, super hot. But when you charge it with like a lower powered charger board, charger brick, it stays cool. And I'll plug it in and I'll show you how that works too. So once plugged in, produces a red LED, and then when it's fully charged at 4.2, it'll turn green and it'll stop charging. So the way it's currently configured, as soon as you plug it in, the light stays on. So all you gotta do is loosen the bulb a little bit, and then you can actively monitor your charge voltage. Yeah, I actually didn't calibrate this circuit board before I put it on. I was kind of in a hurry, but on the back of the circuit board, let me see here, there's a little Phillips screw that you can adjust it to dial in the accuracy of the voltmeter. So this will probably kick off at like 4.3 or whatever volts. But all you got to do is use like a high-end multimeter to measure the voltage of the battery, and just dial it in the meter into that voltage to get an accurate reading. But this is pretty much a fully charged battery anyway, so I don't want to. I'm just going to see how long I can use this when I just use it for like normal means. That's another thing. It doesn't like always start resonating at first, right? Sometimes you'll turn it off and turn it on, and it won't turn on, right? Till you just get it to resonate, but it always eventually turns on. And this thing's lightweight, and eventually I might just make it even more compact and slimmer so I can slide it into a backpack or a cargo pocket or something in the future. And of course I got this cover that I printed just to protect the coil. And everything screws together, so it's easy to take apart and tweak and test. And onto the circuit. Okay, so like I said, the outer wire is the L1 coil. I'll call it that because it's the one that's actually excited by the 3055. And when full wrap, the smaller coil is a 26 gauge. It's got three wraps, or 3 layers. So I wind it, and then I wind it back, and then I wind it back. And I think as you increase it, you'll actually increase the efficiency. But then once you get to a certain point, it just requires high voltage to turn on. Or you can adjust the L1 coil just to tune it to whatever your load is. But my preferred load is just a one bulb deal. You can power 3 bulbs if you want or more, but I just want to do the one. Now with the 3055, I actually threw a diode in, Bedini style, just to protect the transistor, just in case. I don't know if it's helping or not, but I burned up a few transistors when I was experimenting, and I haven't burned this thing up yet. And yeah, so the 18650 is wired to the USB board, and then to the boost, and then to the SGR 3.0 circuit. And this is just a better wiring diagram of the board. So if you've never done it, you wire the positive of the lithium ion cell to the B plus, and I got this upside down actually. The B plus to the positive, B minus to the negative, and then the M positive goes to the positive in on the boost converter, and likewise.